Dear students, welcome. Today we shall solve some problems on thrust on curved surfaces. First problem will be a hemispherical surface of radius A is immersed in a liquid of density rho with its center at a depth h and its base inclined at an angle theta to the horizontal. Base is inclined at an angle theta to the horizontal. Find the resultant thrust on the curved surface. This is number one part. This is part number one. Also, prove that W minus V whole square plus H square is constant. V and H being the resultant vertical and resultant horizontal thrust, and W the weight of the displaced liquid. First, we shall draw the diagram. Hemispherical surface of radius A is immersed in the liquid. Center at a depth h. Center at a depth h. Suppose it will be like this. This is the center, suppose. This is hemisphere. Center, this. At the depth h. This is at the depth h. C is the center. You may write like this. And the hemisphere, it is inclined at an angle theta. At an angle theta. It is at an angle theta. Suppose OA, this is B. Suppose this T thrust on the plane base. W is the weight of the displaced liquid. V resultant vertical thrust. Also H resultant horizontal thrust on the curved surfaces. This is theta. This angle is theta. And what will be this angle? This angle will be 90 degree minus theta. Consequently, if this angle is 90 degree minus theta, this angle will be equal to theta. This angle will be equal to theta. This is 90. This is theta. It will be 90 degree minus theta, and consequently, this angle will be equal to theta. Now, let me write. Suppose this is C. Is immersed in a liquid of density rho with its center at the depth h and its base inclined at an angle. Center of the base. Let C be the center of the base of the. Be the center. Let C be the center of the base of the hemispherical shell. Of the hemisphere. You may write the hemisphere of the hemisphere. This angle is theta. It is already given. C is at a depth h below the free surface. Next, write let capital T be the thrust on the plane base. Thrust on the plane base. of the hemisphere. Let W is the weight of the displaced liquid, it is given, and P is the resultant vertical thrust on the curved surface. H is the resultant horizontal thrust on the curved surface. It is given in the question. Therefore, we need not write here. A is the radius of the hemisphere. A is the radius of the hemisphere. Now, let and rho is the density of the liquid. Now, T, this is equal to thrust on plane base. Here, you see, what will be the thrust on the plane base? This is equal to here, you see, area of this circle, and pressure at its center of gravity, C. Pressure at the center of gravity, C. What is the pressure? H rho Z. What is rho? Density of the liquid. What is H? The depth of C below the free surface. This is the free surface. You may write here free surface. Therefore, T will be equal to H rho Z into H into area of this. Since A is the radius of the hemisphere, therefore the area of this circle will be equal to pi a square. T is equal to this. What is W? Equal to weight of the displaced liquid. W, this is equal to weight of the displaced liquid. What is weight of the displaced liquid? Weight W, this is equal to M into Z. First write here Z. If we write here Z, then we will have to write here mass. Density is equal to mass by volume. Mass is equal to volume into density. If you write rho density, then the volume of the hemisphere. What is the volume of the hemisphere? 2 by 3 pi a cube. 2 by 3 pi a cube rho Z. This is the volume of the hemisphere. Weight of the displaced liquid is equal to this. Now, what is H? Resultant horizontal thrust. What is the contribution of T in this direction? What will be the contribution of T in this direction? Here you see this angle is theta. Consequently, this angle is pi by 2 minus theta. Suppose if you draw here, then what will be this angle? This angle will be equal to theta. Contribution of this divided by T equal to sin theta. There, it will be pi by 2 minus theta, sin theta. Therefore, this will be equal to T sin theta. H is equal to T sin theta. Also, V this is equal to resultant vertical thrust equal to W plus contribution of T in vertical direction will be equal to T cos theta. We have to find the resultant thrust on the curved surface. Let R be the resultant thrust on the curved surface. Let R be the resultant thrust on the curved surface. R is the resultant thrust on the curved surface. Therefore, R is equal to R square, this is equal to V square plus H square. V square plus H square. Therefore, R square equal to, what is V? W plus T cos theta whole square plus H equal to T sin theta whole square. This is equal to W square plus T square cos square theta plus sin square theta plus 2 times of WT sin cos theta, WT cos theta. This is equal to, what is W? 2 by 3 pi a cube pi rho z a cube. This whole square plus, what is T square? Pi rho z h, rho z h a square. This is whole square plus 2 times of W means, you may write here 2 by 3 pi rho z a cube into T. T means pi rho z h a square into cos theta. Into cos theta. You may write like this. You may write like this. Resultant thrust on the curved surface will be equal to this. Now, this means R square. This is equal to R square, this is equal to pi rho z a square, pi rho z a square whole square. Take it common. Then you will get 4 by 9 a square from this. 4 by 9 a square plus pi rho z a square. It will be a square. It will be a square plus 4 by 3 pi rho z a square. It will be equal to AH cos theta. Am I right? AH cos theta. AH cos theta. You will get this. This means R equal to pi rho z a square into, you may write 4 by 9 a square plus h square plus 4 by 3 AH cos theta whole to the power half. You may write like this. This is the resultant thrust on the curved surfaces. This is the resultant thrust on the curved surfaces. Now we are going to prove the second part. Second part, to prove the second part. Now, second part. Second part. Now H is equal to H is equal to T. H is equal to T sin theta. V, this is equal to W plus T cos theta. W plus T cos theta. We got this. This means W minus V whole square plus H square. This is equal to V minus W or W minus V whole square plus H square equal to minus T cos theta whole square plus T sin theta whole square. This is equal to T square into cos square theta plus sin square theta. This is equal to T square. What is T? Rho G H pi a square whole square. This is equal to constant. This is equal to constant. Thus, the problem has been solved. Let us take another problem. Let us solve this problem. Here, a solid right circular cone of vertical angle twice alpha, means semi-vertical angle is alpha, is just immersed in water so that one generator is in the surface of the liquid. One generator is in the surface of the liquid, provided the resultant thrust on the curved surface of the cone is to the weight of the fluid displaced by the cone as this. Resultant thrust is to weight. This is equal to this is to this, number one part. And second part is, it is inclined to the axis of the cone at an angle cot inverse. First, you see, one generator is in the surface of the liquid. One generator is in the surface of the liquid. Suppose the cone is like this. This is the cone. It is the plan dish. OAB. Also C. Suppose H is the height of the cone and it is given that alpha is the semi-vertical angle. Twice alpha is the vertical angle. Resultant thrust, we have to find the resultant thrust and the weight displaced. We find the ratio, resultant thrust and the weight of the liquid displaced. Now see. Thrust on the curved surface, this is T. And H, suppose it is Z will be this, in this way, suppose Z, W. Also, resultant vertical thrust will be like this. Resultant vertical thrust will be like this. You see one thing, this is alpha. It is 90 degree. And what will this is alpha? One thing you see here, if you draw a line like this, horizontal line, if this is a horizontal line, suppose this is a horizontal line, then it is also horizontal line, this is also horizontal line, and this line cuts this. These two horizontal lines and this line cuts this, therefore this angle alpha this angle is alpha, these two horizontal lines, and this angle cuts this. And if it is alpha, then this angle is also alpha. This angle is also alpha. Therefore, this angle is alpha. This angle is alpha. This angle is alpha. Consequently, this angle is also alpha. This angle is alpha. 1 minute. This angle is alpha. Now see, let O be the vertex of the cone with its generator OA in the effective surface, means free surface. In the effective surface. Let T be the thrust on the plan base. On the plan base of the cone. And let H be the resultant horizontal thrust on the curved surface. And V be the resultant vertical thrust on the curved surface. On the curved surface. Now, one generator is in the effective surface. Resultant thrust on the curved surface is to the weight display. Weight of the displaced liquid. Now T is equal to, what is T? This is equal to pressure at C. You see here, pressure at C. What is the pressure of at C? G rho into H. H means the vertical distance from C to the effective surface. C this vertical line. What will be the distance of this? This is a cone, and this angle will be 90 degrees. It is alpha. Therefore, what will be this? This divided by OC equal to sin alpha. Therefore, this is equal to sin alpha. It will be sin alpha. What sin alpha? H sin alpha. H, it will be H sin alpha. H sin alpha into pi AC square. Pi into AC square. AC divided by OC. AC divided by OC. This time this is 90 degree. AC divided by OC. Perpendicular by base. Equal to tan. H tan alpha whole square. Here you see the area of this portion, area of the circle will be equal to pi r square, pi into AC square, pi into H tan alpha whole square. And pressure at the center of gravity, pressure at C, this is equal to H rho G. G rho into this perpendicular distance will be equal to this distance will be equal to H sin alpha, definitely. Where H is the height of the cone. Height of the cone. h is the height of the cone. OC is equal to h. H is the height of the cone. Perhaps you understand this. This implies pi rho g h cube tan square alpha into sin alpha. You will get tan square alpha into sin alpha. T is equal to this. T is equal to this. Now W. What is W? What is W? W this is equal to weight. Write here G. We have to write here mass. Rho. Rho is the density of the liquid. Rho density of the liquid. Rho. You have to write here the volume. What is the volume of the displaced liquid? Volume is equal to 1 by 3 pi r square h. Pi r square h or a square h. What is this? AC square. Here also you may write here. Here AC is the height of the cone and the AC. This is equal to OC tan alpha. This is equal to H tan alpha. You may write here like this. This is equal to 1 by 3 pi. AC means H tan alpha whole square. Again H rho g. Again H rho g. This is equal to 1 by 3 pi rho g h cube tan square alpha. H cube tan square alpha. You may write like this. 1 by 3 pi rho g h cube tan square alpha. W is equal to this. W is equal to this. Now, H is equal to resultant horizontal thrust. What will be the resultant horizontal thrust? Contribution of T in this direction will be equal to T cos alpha. V plus contribution of D. It will be 90 degree minus alpha. This will be equal to alpha. Contribution of D H tan T sin alpha. This is equal to W. This means V equal to W minus T sin alpha. W minus T sin alpha. Let R be the resultant thrust on the curved surface. Thrust on the curved surface. Let R be the resultant thrust on the curved surface. Then R is equal to R square. This is equal to V square plus H square. R square, this is equal to V square plus H square. R square will be equal to V square plus H square. To the axis of the cone at an angle. Axis of the resultant thrust makes an angle with the axis of the cone at an angle. I am writing here. This means R square equal to W minus T sin alpha whole square plus T cos alpha whole square. T cos alpha whole square. This means R square equal to W square plus T square sin square alpha plus cos square alpha minus twice WT sin alpha. You will get this. Or R square, this is equal to W square plus T square minus twice Wt sin alpha. Twice Wt sin alpha. Now I am writing here. This means R square, this is equal to, what is W square? 1 by 3 pi rho z h cube tan square alpha whole square plus t square. T square means pi rho z tan square alpha sin alpha whole square minus twice W. W means 1 by 3 pi rho z h cube tan square alpha into pi rho z h cube tan square alpha into sin alpha. Sin alpha into another sin alpha here. Here you see another sin alpha here. This means R square equal to 1 by 3 pi rho z h cube tan square alpha whole square. Take it common. Take it common. Then you will get here 1 plus here pi rho z h cube tan square alpha. Here you will get 3 sin alpha whole square pi rho z h cube tan square alpha pi rho z h cube tan square alpha plus no, not plus, minus 2 by 3 into 9. 2 by 3 into 9. Sin theta, sin alpha into sin alpha means sin square alpha. Sin alpha into sin alpha means sin square alpha. You will get this. You will get this one. Now, this means R square, this is equal to, it is nothing but W square. 1 plus 9 sin square alpha minus, it will be 6 sin square alpha. This means W square 1 plus thrice sin square alpha. This means R by W. This is equal to root of R. 1 plus 3 sin square alpha. R by W. Divided by 1. This means R is 2W. This is equal to root of R. 1 plus 3 sin square alpha is to 1. Therefore, this problem, first part has been proved. First part has been solved, the second part. Now second part. What is the second part? The second part is, we are to find the angle between the resultant thrust on the curved surface with the axis of the cone. With the axis of the cone. Now you see, in this direction, suppose this is H, this is P, and the resultant thrust is this. Resultant thrust is this. We have to find, and the axis of the cone, OC is like that. Also, OC makes an angle alpha. OC, this makes an angle alpha with the horizon. Therefore, we have to find a angle theta. Suppose theta made by the resultant thrust with the horizontal line, with the horizon. let let the resultant thrust on the curved surface R makes an angle theta with the horizon, with the direction of HV, with the direction of H, with the direction of H. Now, tan theta is equal to, therefore tan theta, what will be tan theta? Tan theta will be equal to, if tan theta is equal to V by H, this is equal to V divided by H. What is V? V plus this is equal to W minus this. Therefore, it will be W minus T in this direction T sin alpha, and it will be T cos alpha. This will be T cos alpha. Now, what is you must understand this one. What is W? You see, what is W? W is equal to weight of the displaced liquid. First, find the volume. 1 by 3 pi r square h. Pi r square h. R square means AC square. AC square. AC. What is AC? AC divided by h tan alpha whole square into h. H cube tan square alpha into h into rho z minus T. What is T? Equal to 0 into this distance is equal to h sin alpha. H sin alpha into pi r square, pi h square tan square alpha, tan square alpha. T, this is equal to 0 h tan alpha not tan alpha. This is equal to sin alpha. T is equal to this, and you will have to write sin alpha also. You will have to write sin alpha also. 0 h sin alpha pi h square tan square alpha into cos alpha. This is the case. Into cos alpha. This means tan alpha, tan theta equal to, this is equal to pi rho z, pi rho z, pi rho z, rho z pi will be cancelled. H cube terms will be also cancelled. Not only that, tan square alpha will be cancelled. And in the numerator, you will get 1 by 3 minus. In the numerator, you will get 1 by 3 minus. It will be sin square alpha. Here it is sin alpha into cos alpha. Here it is sin alpha into cos alpha. This means tan theta, this is equal to 1 minus thrice sin square alpha divided by thrice sin alpha into cos alpha. This is equal to sec square alpha minus thrice tan square alpha divided by thrice tan alpha. You may write like this. This is equal to 1 plus tan square alpha minus thrice tan square alpha divided by thrice tan alpha. This is equal to 1 minus twice tan square alpha divided by thrice tan alpha divided by thrice tan alpha. Now you see we have to find the angle, this angle. What is this angle? Theta plus alpha. Now required angle. This is equal to theta plus alpha. Required angle, this is equal to theta plus alpha. You may write here tan inverse tan theta plus alpha. You may write like this. This is equal to tan inverse. Tan theta plus alpha means you may write tan theta plus tan alpha divided by 1 minus tan theta into tan alpha. You may write like this. You may write like this. This is equal to tan inverse. What is tan theta? 1 minus twice tan square alpha divided by thrice tan alpha plus tan alpha divided by 1 minus twice tan square alpha thrice tan alpha into tan alpha. You may write like this. This means this is equal to tan inverse. Now multiply numerator and denominator by 3 tan alpha. 1 minus twice tan square alpha plus thrice tan square alpha divided by 3 tan alpha minus tan alpha plus twice tan cube alpha. You may write like this. This is equal to tan inverse 1 plus tan square alpha divided by twice tan alpha plus this. You may write like this. These two terms, numerator denominator, will be cancelled. This is equal to tan inverse 1 by twice tan alpha. Tan inverse 1 by twice tan alpha. Thus, theta plus alpha, this is equal to tan inverse twice 1 by twice tan alpha. This implies tan theta plus alpha equal to 1 by twice tan alpha. This implies cot theta plus alpha. This is equal to twice tan alpha. This means theta plus alpha. This is equal to cot inverse twice tan alpha. Thus, you see the second part has also been proved. Let us try to solve this problem. A solid cone is just immersed with a generating line in the surface. A solid cone, it is just as the previous problem. It is just as the previous problem. OAB be the cone. C is the center of the base. OC is the axis of the cone. Alpha is the twice alpha, vertical angle. Alpha is the H is the resultant thrust on the curved surface, resultant horizontal thrust. T is the thrust on the plane base. Thrust on the plane base. Therefore, it is horizontal. It is horizontal. It is horizontal. It will be equal to alpha. And W P is the vertical angle. Right here, let the generator OA of the cone OAB be in the free surface. Be in the free surface. Be in the free surface. O is the vertex. O is the vertex of the cone. O is the vertex of the cone. Let T be the thrust on the plane base. Plane base. Let H be the resultant horizontal thrust on the curved surface. Thrust on the curved surface. Again, let V be the resultant vertical thrust on the curved surface. Resultant vertical thrust on the curved surface. W is the weight of, and W, this is equal to the weight of the displaced liquid. Weight of the displaced liquid. W is equal to weight of the displaced liquid. Theta is the angle made by the resultant thrust on the curved surface with the vertical. Therefore, T equal to, you see, therefore T, this is equal to G rho, rho is the density of the liquid, G rho into this distance. What will be this distance? Will be equal to OC sin alpha. OC is equal to H sin alpha into pi r square, pi AC square, means pi H tan alpha whole square. This is equal to G rho pi H cube tan square alpha sin alpha. T is equal to this. Rho is the density of the liquid. Rho is the density of the liquid. W equal to weight of the displaced liquid. W, this is equal to the weight of the displaced liquid. Displaced liquid. This is equal to G rho, the volume 1/3 pi r square H square tan square alpha into H. This means W equal to 1/3 pi G rho H cube tan square alpha. H cube tan square alpha. Now tan theta equal to tan theta, this is equal to, with the vertical resultant thrust, this is horizontal H, this is vertical, this is resultant thrust, makes angle with the vertical. Then tan theta is equal to H by V. Tan theta, this is equal to H divided by V. This is equal to, what is H? What is H? H is equal to T. What is H? H is equal to T cos alpha. What is V? V equal to it will be in the positive sign, in the positive direction. V equal to W minus V plus this is equal to W minus T sin alpha. W minus T sin alpha. It will be like this. This means tan theta this is equal to, what is H? T. T this is equal to G rho pi H cube tan square alpha into sin alpha cos alpha. W means 1 by 3 pi G rho H cube tan square alpha minus G rho pi H cube tan square alpha sin alpha into sin alpha means sin square alpha. It will be like this. These terms from this to this will be cancelled. From this to this will be cancelled. From this to this will be cancelled. You will get sin alpha cos alpha divided by 1 by 3 minus sin square alpha. This is equal to thrice sin alpha cos alpha divided by 1 minus thrice sin square alpha. It will be like this. And this means 1 minus thrice sin square alpha into tan theta. This is equal to thrice sin alpha into cos alpha. This will be equal to this. Let us take another problem. Let us solve this problem. A cone whose vertical angle is twice alpha has its lowest generator horizontal. This time lowest generator horizontal and is filled with liquid. Prove that the resultant thrust on the curved surface is this. Now here you see the cone will be like this here, this time. Lowest OAB. The effective surface, A is in the effective surface here. Here A is in the effective surface. Alpha, alpha. And this angle. T thrust on the plane base. This thing we have to write like this. H this is alpha. This is alpha. This is 90 degree minus alpha. And you see this is alpha, vertical line. If you take the vertical line with the horizontal, this is horizontal. This is 90 degree. This is 90 degree. Also this is 90 degree. This is horizontal. Horizontal. If you like is the horizontal line here, then horizontal line. Now see here, this is alpha, this is 90 degree. What will be this? 90 degree minus alpha. This angle will be 90 degree minus alpha. And therefore, if you put the vertical angle here, in this way, then you see this angle and this angle will be again 90 degree minus alpha. This angle will be 90 degree minus alpha. Therefore, this angle will be equal to alpha here. In this case, this angle will be alpha. Let OA be beta known. Beta known. Filled with liquid. Liquid such that the generator OB here, OB is horizontal. You see, lowest generator horizontal. Liquid such that the generator OB is horizontal. Let T be the thrust on the plane base. Thrust on the plane base. Similar questions. Plane base. Let H and P be respectively the resultant horizontal thrust and resultant vertical thrust. Resultant vertical thrust. Resultant vertical thrust on the curved surface. Resultant horizontal thrust and resultant vertical thrust on the curved surface. Therefore, T equal to therefore T equal to T, this is equal to, what is T? This is equal to pressure at the center of gravity C. Pressure at C, 0 into this distance. What is this distance? What will be this distance? And you see here, this is alpha. This is 90 degree minus alpha. This is 90 degree minus alpha. This is alpha, this is 90 degree minus alpha. Consequently, these two lines are vertical, this line cuts. Therefore, this is alpha. If this is alpha, this angle is equal to alpha. 90 degree minus alpha, consequently this angle is equal to alpha. This angle, this, alpha. Since this angle is alpha, therefore this angle will be equal to alpha. These two lines are vertical. This line cuts vertical. This line cuts vertical. This line cuts. This angle is equal to this angle. Therefore, this is alpha. This is equal to alpha. Therefore, 0. What will be this distance? Equal to AC. This is equal to AC. If it is alpha, this is 90 degree. This is alpha. This divided by this equal to cos alpha. AC cos alpha. AC cos alpha. You will get AC cos alpha into pi. This is AC. Into pi AC square. AC square. This is equal to 0. What is AC? AC cos alpha. What is AC? AC is equal to this divided by OC equal to tan alpha. This is equal to tan alpha. Therefore, this is equal to your OC tan alpha. OC tan alpha is equal to H tan alpha into cos alpha into pi H tan alpha whole square. Where you may write here where rho equal to density of the liquid. Rho is equal to density of the liquid. Not only that. H is equal to height of the cone. Height of the cone. And H is equal to height of the cone. You may write this means T this is equal to 0 pi H cube tan cube alpha into cos alpha. Tan cube alpha into cos alpha. Tan cube alpha into cos alpha. W equal to, wait, you may write G, rho, the volume of the cone. What will be the volume of the cone? 1 by 3 pi r square h, pi AC square into AC. What is AC? H tan alpha whole square into H. W equal to weight of the liquid within the cone. Liquid within the cone. Here this will be effective surface because A is in the effective surface. Means free surface. Now W is equal to 1 by 3 pi 0 h cube into tan square alpha 0 cube into tan square alpha. You will get this one. H is equal to T cos alpha. P equal to W plus P equal to W plus T sin alpha. T sin alpha. Now we have got this one. What we are going to prove? We are going to prove that the resultant thrust, this is equal to root over something 1 plus 15 sin square alpha times the weight of the liquid of the cone. Therefore, let R be the resultant thrust on the curved surface. Be the resultant thrust on the curved surface. Resultant thrust on the curved surface. Here T equal to this. Density, height of the cone. T is equal to, we can remove this one also. Thrust on the curved surface. Therefore, R square equal to V square plus H square. This is equal to what is V? W plus T sin alpha whole square plus H square T cos alpha whole square. This is equal to W square plus T square plus twice WT sin alpha. You will get this. This is equal to, what is W? You may write here 1 by 3 pi 0 h cube tan square alpha whole square plus T square. What is T? Equal to 0 pi h cube tan cube alpha cos alpha whole square plus twice W 1 by 3 pi z rho h cube tan square alpha into 0 pi h cube tan cube alpha cos alpha into also sin alpha into sin alpha. This is equal to 1 by 3 pi 0 h cube tan square alpha whole square. Take it common. You will get here 1 pi 0 h cube 1 plus, you will get thrice tan alpha into cos alpha whole square. Thrice tan alpha into cos alpha whole square. You will get this. Plus, here you will get here 9 into 2 by 3. 9 into 2 by 3 pi 0 h cube tan square alpha pi 0 h cube tan, here 1 tan alpha will be left, 2 by 3 all terms will go tan alpha into tan alpha into cos alpha sin alpha into cos alpha sin alpha. We will get this one. You see, we will get this one. Now, this means r square equal to, this is nothing but w square into 1 plus sin alpha by cos sin square alpha, 9 sin square alpha plus 6. What will be this? Cos alpha will cancel, sin square alpha. This means r square. This is equal to w square 1 plus 15 sin square alpha. 15 sin square alpha. This means r equal to w into root of r 1 plus 15 sin square alpha. Therefore, thrust on the curve, resultant thrust on the curved surface is root over 1 plus 15 sin square alpha times the weight of the liquid within the womb. That's all. Let us solve this problem. A solid hemisphere is placed with its base inclined to the surface of a liquid in which it is just totally immersed at a given angle alpha. You see, suppose this is the free surface. This is the free surface. Hemisphere. This is the hemisphere. This is the hemisphere. Suppose this is O, A, this is C. Suppose it is B, and with its base inclined to the surface of the liquid, just to the mass. At a given angle alpha. This angle is alpha. This angle is alpha. What will be this distance? Same thing. W, P, H, and T. T. If it is T, you see here, it is vertical. This is also vertical. It is alpha. What will be this? 90 degree minus alpha. Consequently, this angle is 90 degree minus alpha and this angle is alpha. This angle is alpha. Now, let totally immerse on a liquid. So that the resultant thrust on the curved surface. Let O is, let OAB be the hemisphere. With O is in the just totally immerse in the effective surface or free surface. In the free surface. Let T be the surface, T be the thrust on the plan base. Plan base. And let H and V be respectively the resultant horizontal thrust and the resultant vertical thrust. Thrust, resultant horizontal thrust and the resultant vertical thrust on the curved surface. Resultant vertical thrust on the curved surface. Now, the universe we have written in the right way. We have written in the right way. Therefore, T equal to pressure at the center of gravity, C. Pressure at C. What is pressure at C? G rho into H means this distance. What is this distance? Equal to OC sin alpha. A sin alpha. A sin alpha into pi a square. This means T equal to G rho pi a cube sin alpha. W, this is equal to W. What is W? Wait, 1 or 2 by 3. 2 by 3 pi a cube. into rho. This is the volume multiplied by rho mass. Multiply it by Z. That means weight. Resultant thrust, this is equal to twice W. We will have to prove this. This is equal to this. H is equal to T. H is equal to T. H. This is alpha. If this is alpha, and this will be equal to alpha, what is H? Equal to T sin alpha. V. This is equal to W plus T cos alpha. W plus T cos alpha. We have to find the resultant thrust. Now R square. Now let R be the resultant thrust. Thrust on the curved surface. Let R be the resultant thrust on the curved surface. R be the resultant thrust on the curved surface. Therefore, R square equal to V square plus H square. This means R square equal to W plus T cos alpha whole square plus T sin alpha whole square. This means R square equal to W square plus T square cos square alpha plus sin square alpha plus twice WT sin cos alpha. Not sin alpha. It is cos alpha. WT cos alpha. This means tan alpha is equal to this means R square, this is equal to W square plus T square plus twice WT cos alpha. This means R square is equal to W square means 2 by 3 pi 0 a cube whole square plus pi 0 a cube sin alpha whole square plus 2 times of 2 by 3 pi 0 a cube into pi 0 a cube sin alpha into cos alpha. Into cos alpha. You will get this one. See very carefully. Now we have to find what? R, this is equal to twice W. If tan alpha equal to 2, what does it mean? R by W equal to 2. Therefore, take this common. 2 by 3 pi 0 a cube whole square. Take this common. If you take this common, you will get 1 here plus pi 0 a cube. It will go 9 by 4 sin square alpha plus here also 4 by 3 9 by 4 into 4 by 3 pi 0 a cube pi 0 a cube. You will get sin alpha into cos alpha. Right? Sin alpha into cos alpha. This means R square, this is equal to, it is nothing but W square 1 plus 9/4 sine square alpha. 9/4 sine square alpha plus thrice sine alpha into cos alpha. Plus thrice sine alpha into cos alpha. This means r square, this is equal to w square. You are given that tan alpha this is equal to 2. Tan alpha this is equal to 2. Therefore, tan alpha this is equal to 2. You may write here 1/4. 4 plus 9. What is sine square alpha? Sine square alpha means sine square alpha divided by sine square alpha into plus cos square alpha. It will be tan square alpha divided by tan square alpha plus 1. It will be like this. Plus 3 times of 3 into 4, 12 times of tan alpha divided by tan square alpha plus 1. Tan square alpha divided by tan square alpha plus 1. This means r square this is equal to w square divided by 4. 4 plus 9. This is equal to 2 square means 4 divided by 4 plus 1 plus 12. 2 4 plus 1. Since tan alpha equal to 2. Since tan alpha this is equal to 2. Thus putting tan alpha is equal to 2 here. Now, this means r square this is equal to w square divided by 4. 4 plus 36/5 plus 24/5. This implies r square equal to w square divided by 4 into 5, 20 plus 36 plus 24. This means r square is equal to w square divided by 4 into this is 60, 80 divided by 5. 5, 16, 4, 4. This means r square this is equal to 4w square. This implies r is equal to twice w. Thus, r this is equal to 2 times of weight of the displaced liquid. Weight of the displaced liquid. If tan alpha is equal to 2. If tan alpha is equal to 2. Weight of the displaced liquid if tan alpha is equal to 2. Alternatively, you may solve this problem as you may suppose that r is equal to 2w. Then you have to prove that tan alpha is equal to 2. Suppose this one, you will have to prove that tan alpha is equal to 2. Suppose this is number A. Suppose this is number A. If alternatively, note, alternatively, let r equal to 2w. This means r square is equal to 4w square. R square is equal to 4w square. Therefore, A implies from A you will get 4w square. This is equal to w square 1 plus 9/4 sine square alpha plus thrice sine alpha cos alpha. You may write like this. This means 4 equal to. This means 4, this is equal to 1 plus 9 by 4 sine square alpha, means tan square alpha divided by tan square alpha plus 1. You may write like this. Plus 3 tan alpha divided by tan square alpha plus 1. You may write like this. This means 16 equal to 4 plus 9 tan square alpha divided by tan square alpha plus 1 plus 12 tan alpha divided by tan square alpha plus 1. This means 12 into tan square alpha plus 12. This is equal to 9 tan square alpha plus 12 tan alpha. This means thrice tan square alpha minus 12 tan alpha plus 12. This is equal to 0. This means tan square alpha minus 4 tan alpha plus 4. This is equal to 0. Tan alpha minus 2 square equal to 0. This means tan alpha minus 2 equal to 0. This means tan alpha this is equal to 2. You may, right? You may solve this this way also. If you put tan alpha equal to 2, then you will get r is equal to 2w. If you suppose that r is equal to 2w, then you will find that tan alpha is equal to 2. In such way also you may solve this problem. Let us take another problem. Let us try to solve this problem. A hollow cone without weight, closed and filled with water, is suspended from a point in the rim of its base. If phi be the angle which the direction of the resultant pressure makes with the vertical. I am going to tell that phi is the angle which the direction of the resultant pressure makes with the vertical. Then we have to prove that cot phi equal to this one. Now let us see. Suppose this one is like that. Suppose one is like that. OAB is the bone. It is 0. In the position of equilibrium, it will be suppose this angle is suppose theta. Also semi-vertical angle is alpha. H is the resultant horizontal thrust. If this angle is theta, what will be this angle? 90 degree minus theta. This angle will be 90 degree minus theta. If this angle is 90 degree minus theta, what will be this angle? What will be this angle? This angle will be also 90 degree minus theta. Consequently, this angle is equal to theta. Consequently, this angle is theta. Also, you may find that this is vertical line. This is vertical line. If you extend the vertical line to this angle is theta. This angle is theta. This is intersecting here. Therefore, this angle is theta. AB is intersecting this. Therefore, this angle. If this angle is theta, what will be this angle? This angle will be equal to theta. Once you get this angle is equal to theta. If this angle is equal to theta, this angle is 90 degree minus theta, therefore this is equal to theta. Very simple. Now let O be the vertex of the cone. Center of the base, and C be the center of the base of the cone. Suppose this one. Next, suppose that center of the base of the cone, OC equal to height of the cone, height of the cone. This is equal to HC, height of the cone. This is equal to H. Suppose HC. In the position of equilibrium, the line joining A and G. What is G? The center of gravity of the cone filled with liquid. Center of gravity of the cone filled with liquid. In the position of equilibrium, the line joining A and G, liquid, will be vertical. Clearly, one thing is this: A is it is filled with water. Is suspended from a point in the rim of its base. It's suspended from a point in the rim of its base. What does it mean? Suspended from a point in its rim. A is in the effective surface and A is a point. The cone is suspended here. Therefore, AG will be vertical. A and G, the line, vertical line joining A, vertical line through A, will also pass through G. Now let theta be the angle made by the base of the cone mixed with the vertical. Let the base of the cone makes an angle theta with the vertical. Angle theta with the vertical. Theta with the vertical. Makes an angle theta with the vertical. Now let T be the phi angle with the vertical, resultant thrust with the vertical. Phi resultant thrust with the vertical. Yes, I will have to remember this. Phi resultant thrust with the vertical. We have to prove this one. Let T be the thrust on the plane base. Let T be the thrust on the plane base. Therefore, T equal to 0 and into this distance. What is this distance? Equal to AC. Oh, this is theta, means this is 90 degree minus theta. Therefore, this angle will be also equal to theta. This is theta, this is theta. What is this? This side equal to AC cos theta. AC cos theta. And pi into AC square. AC square. This means T is equal to 0 pi AC whole cube. AC means H. AC, what is AC? AC means H. Oh. AC means H tan alpha. This will be whole cube cos theta. Whole cube cos theta. Whole cube cos theta. Now, one more thing we'll have to calculate here. From triangle ACG we get. From triangle ACG we get this is 90 degree. This is theta. This is 90 degree minus theta. AC divided by CG. AC divided by CG. This is equal to cot theta. Cot theta. This means what is AC? AC equal to H tan alpha divided by CG equal to 1 by 4 H equal to cot theta. This means H will be cancelled, 4 tan alpha cot theta. Am I right? This is 90 degree. Therefore, CG AC by CG 1 by 4 tan alpha equal to cot theta. Or tan theta equal to what? Tan theta is equal to 1 by 4 cot alpha. Tan theta will be equal to 1 by 4 cot alpha. Perhaps you understand this. AC by CG. AC by CG equal to cot theta. From this diagram, from this triangle ACG, we get this one. 1 by 4 tan theta is equal to, this result will be required later on. Tan theta is equal to 1 by 4 cot alpha. This result will be required later. Now T is equal to this. W equal to weight of the liquid within the form. Weight of the liquid within the form. 1 by 3 pi r square h. What is AC? AC, this is equal to h tan alpha. H tan alpha pi r square h into rho into g. This is equal to 1 by 3 pi rho g h cube tan square alpha. H cube tan square alpha. You will get this one. T is equal to this, W is equal to this. Now according to the question, phi is the angle made by the resultant thrust on the curved surface makes with the vertical. Resultant curved surface with the vertical. Phi is the angle made by the resultant thrust with the vertical. Suppose this is R, this is H, this is V. With the vertical, this is theta. Therefore, tan theta. This is not theta. This is phi. Therefore, tan phi. This is equal to tan phi equal to H divided by V. This means cot phi equal to V by H. Cot phi is equal to V by H. Now, V, this is equal to resultant vertical thrust. Thrust on the curved surface. On the curved surface. This is equal to, what is V? W plus T in this direction. In this direction means this direction. What will be this one? T sin theta. T sin theta. H is equal to this. H is equal to resultant horizontal thrust. Thrust on the curved surface. Resultant horizontal thrust on the curved surface. This is equal to H. This is equal to T cos theta. T cos theta. Therefore, cot phi is equal to V by H. Cot phi equal to V by H. This means V equal to W plus T sin theta divided by T cos theta. You will get this one. This means cot phi. This is equal to W. What is W? Right, 1 by 3 pi rho z. I am writing pi rho z h cube tan square alpha plus T means z rho pi h cube tan cube alpha cos theta. Tan cube alpha cos theta divided by z rho pi h cube tan cube alpha. 1 minute. Tan cube alpha cos theta into sin theta. Into sin theta. Into this sin theta. Tan cube alpha cos theta. Tan cube alpha cos theta into another cos theta, cos square theta. It will be cos square theta. Now you see pi cancel, rho cancel, z cancel, h cube also cancel, h cube cancel, tan square alpha will be also cancelled. Therefore Therefore, I can write like this. This means cot phi. This is equal to 1 by 3 plus tan square alpha into sin theta cos theta divided by tan alpha, not tan square alpha, this is tan alpha, tan square alpha, tan alpha into cos square theta. Am I right like this? Now we are going to apply this. Tan theta is equal to, in terms of alpha, we will have to write in terms of alpha. Therefore, 1 by 3 plus tan alpha what is this? It will be tan alpha divided by tan theta divided by tan square theta plus 1 tan alpha. What will be this? 1 divided by tan square theta plus 1. 1 divided by tan square theta plus 1. You will get this one. Now, from this line, we will get this cot phi. This is equal to, tan square theta plus 1 plus thrice tan alpha into tan theta. Here tan square theta plus 1, we are multiplying this tan alpha, right? And 3 also. This means cot phi, this is equal to tan square theta is equal to this, put 1 by 16 cot square alpha plus 1 plus 3 tan alpha 1 by 4 cot alpha 3 tan alpha, simply 3 tan alpha. Now, this means cot alpha, cot phi, this is equal to 1 by 16 cos square alpha, 1 by 16 cos square alpha plus, it will be 1 plus 3 by 4. 1 plus 3 by 4 divided by 3 by cot alpha. You may write 3 by cot alpha, or multiply by 16 cot alpha. You will get cot cube alpha plus 16 cot alpha plus 12 cot alpha divided by 16 into 3. 16 into 3. This is equal to cot cube alpha plus 28 cot alpha divided by 48. This cot phi equal to this. Cot phi, this is equal to cot cube alpha plus 28 cot alpha divided by 48. Dear students, thanks for attending the class. Thank you.